Okay, so here's the day one module review. I am going to try and make it as short as possible, which means I will be going really fast when I talk, but remember, we've done this before. So if you need to zip through parts that you understand and only go to the parts you don't understand, awesome. Here we go. The beginning we had 4 dots, 1 hour we had 7 dots, 2 hours we had 10 dots, and 3 hours we had 13 dots. Beginning means 0, so we're starting with time 0, and we had 4 dots. Time 1 we had 7 dots. Time 2 hours we had 10 dots, and then 3 hours we had 13 dots. So when we fill out our table, it starts off with 4, and then we have 4 plus 3, and then we have 4 plus 3 plus 3, then we have 4 plus 3 plus 3 plus 3. Again, that's because we are adding by 3 as we go down. When we simplify, we have 4 plus 3, but we want to simplify that to just times 3 after the 3 because we added by 3 times. Then we have 4 plus 3 times 2 because we added by the 3 twice. Then we have 4 plus 3 times 1 because we added by the 3 once. And then we have 4 plus 3 times 1 because times 0 because we didn't add by any 3's. Okay? How many are we going to have after 4 hours? Well, add it by 3 and we get 16. After 5 hours, add by 3 again and we get 19. This is arithmetic because we are adding by 3. The recursive is f of n equals f of n minus 1 plus 3, because that's what we added by. And then we have to give a start of the value, which is going to be our start of the table, which is going to be f of 0 equals 4. Where did I get that f of 0 equals 4? Well, because my table started with a 0 and a 4. Recursive, you always have to show that you start with a 0 and the 4. And remember, in a recursive, this means to get to the next number, we have to take the previous number and add by 3. So for example, we had to take our previous number 4 here, add by 3, and that's how we got 7. To get 10, we took our previous number 7, added by 3, and that's how we got our next number, 10. So that's what the recursive does. But we also have to give the start at the table because, yeah, we may know that we're adding by 3, but what number did we start with? So again, this is the start of your table. An explicit goes f of n equals 4 plus 3, and then a regular sized n, and it's just an n because we started our table with time 0. All right, next one, we have 3, 6, 12, 24. So we start off with that 3. Then the pattern that repeats is 3 times 2, and then we have 3 times 2 times 2, and then we have 3 times 2 times 2 times 2. So when we simplify that, we have 3 times 2, but we multiply it by 2 3 times. To represent that, it becomes an exponent. Multiplication, you'll end up having exponents, okay? And here's the rest of the simplified filled out, right? This is how many, that's that pink number that I'm writing represents how many times we multiplied by 2 in our expanded. Make sure your exponent looks like an exponent. If it doesn't, then I will mark it wrong on your final. All right, this is a geometric, right? Because we are multiplying by 2. Its recursive is f of n equals f of n minus 1. And like we said, we are multiplying by 2. But we have to give the start of our table. Well, our table, we started with 0 and 3, so to show that in the recursive, we write f of 0 equals 3. The explicit is f of n equals 3 times 2 to the exponent n. And it's just an n because we start at times 0. It's an exponent because we are multiplying down the table. All right, Miss Rolfe usually has the swim team start with 5 laps. However, many of the swimmers have been coming without their CP pass. So the team will be swimming extra laps. In number 8, Miss Rolfe thinks that each person without a CP pass should double everyone's lap. Well, if I double something, that's geometric because double means multiply by 2. So if I say we start with 5 laps, so if there's nobody late with pass and everybody has their pass, then it's 5 laps. If someone comes late with a pass if someone comes without a CP pass, then that's 10, and then 20, and then 40. Wow, it's a lot of laps, and yes, I do that. Recursive is going to be f of n equals f of n minus 1 times 2, and then our start of our table is 0, 5, so we show that as f of 0 equals 5. Our explicit is f of n equals 5 times 2 to the exponent n, because we are multiplying, so we need an exponent, and it's just an n because we start at times 0 right here. All right, everything that can describe this is geometric, it is exponential, and it is discrete because it's about people without a CP pass. Okay, people you count, right? That's what discrete is. Can you count it? Can there be only counting happening in this case, right? We can only count people. Continuous is when you measure. Can you have part of something? All right, the team captain thinks that each person without a CP pass, 2 laps should be added. Well, that means that this is arithmetic because we are going to be adding by 2. So again, we start with 5 laps, but we add by 2 down our table. So we have 7, 9, 11. So the recursive ends up being f of n equals f of n minus 1 plus 2, given that we started our table with f of 0 equals 5. Very good. Then we have an explicit, which is f of n equals, we start with 5, but we're adding by 2. And then we have just an n after that too, because we start with times 0, and it's regular size because we are doing addition. Only multiplication do we have an exponent. Again, this is still discrete. It's still by how many people come without a CP pass. However, it's arithmetic because we are adding, which means it's a sister to linear. All right, 11. Big hint for 11 through 19, or pretty much all of these, is to make a table. Oh my gosh. Now, in number 11, we're given a list of numbers. Whenever you have a list, this means start with time 1, right? So for example, make my table. We got n, we got f of n. Start with time 1. Well, what that means is 6 is my first number. So my first number is 6. 18 is my second number. So I write 2, and 18 is my second number. Then we have third number is 54. Our fourth number is 162. The math that is happening down this table is we are multiplying by 3. So when we write the recursive, because that's what we're being asked to do, we write it as f of n equals f of n minus 1 times 2, given we start with, at the table, we start with f of 1 equals 6. Okay, same thing with this next one here. Make a table. So I'm not going to write the n and f of n anymore. You should know the n is on the left and f of n is on the right. 60 is my first number, so we start 1 with 60. 30 is my second number, so we have 2 and 30. 15 is my third number, so we have 3 and 15. Now, you will probably say, hey, we're dividing by 2 down our table. But when we use geometrics, we can't say dividing by 2. We have to change it to multiplication, which is times 1/2. Okay, so that's what we're doing down our table. Now, someone in class today made a really good comment. They're like, why isn't it times 2? Well, if we do 60 times 2, that gives us 120. That is not 30, so that does not work. However, if you think about it this way, half of 60 is 30, and that works out. Okay? So we are timesing by 1/2 down our table. So when we write the explicit, because that's what they're asking for, we have f of n equals, we started with 60 times 1/2 to the exponent, because we're multiplying, so we use exponents, n minus 1. Why is it n minus 1? Because we start with time 1. Okay, so we have to represent that in our exponential. All right, let's look at the next one. We're asked for the recursive. So with our list of numbers, first number is 2, second number is -3, third number is -8, fourth number is -13. So as we go down the table, we are subtracting by 5. So when we write the recursive, we have f of n equals f of n minus 1 minus 5, with the start of the table being f of 1 equals 2. All right. If f of 3 is equal to 10, f of 4 equals 16, what is the recursive formula that describes this arithmetic sequences? So that means that this is either adding or subtracting. So let's look at this. We have f of 3 equals 10. When I write that in my table, that's just 310. And we have f of 4 equals 16. Well, I write that in my table, that's 4 and 16. And earlier we said this is arithmetic, so we either add or subtract. Well, to get from 10 to 16 using arithmetic, that's going to be adding by 6. So when we write the recursive, this is going to be f of n equals f of n minus 1 plus 6, given that we started with f of 3 equals 10. Very good. All right, now we're going to write a recursive formula that matches this explicit. So, table again. Table it up. Well, we have just an n, so that means time 0. This 6 is up front, so that's our first f of n. Okay, minus 3 tells us we are minusing 3. And that is all the information we need. So now we can write our recursive formula. F of n equals f of n minus 1. We don't even have to fill out the rest of the table because we got everything we need. We are subtracting by 3, and we started with f of 0 equals 6. All right, now we're going to take the explicit formula that matches with the recursive. So again, make a table. We have f of n equals f of n minus 1 times 11, given we started with f of 1 equals 1. This is the start of our table. This times 11 tells me what we're doing down our table. This is all I need to write out to help me figure out that our explicit is going to be f of n equals, started with the 1, we're multiplying by 11, and that's going to be to the exponent n minus 1 because we started with time 1. We're going to do that again. What is the explicit formula that matches the recursive formula? And then we're going to simplify. So we're going to do what we just did, but then we're going to simplify. So we started with 1 and 15. This is telling me that we are adding by 6. So I can write that explicit f of n equals, first f of n value was 15. Add by 6. And then we have times n minus 1 because we started with times 1. Don't forget the parentheses when it's arithmetic and you have an n minus 1. Now what we're going to do next is we have to distribute. Well, remember, distribute means we take the number in front of the parentheses and multiply it. So 6 times n is a plus 6n. 6 times minus 1 is negative 6. Nothing else changed, so we bring everything else down. Then we combine like terms, which is 15 minus 6. 15 minus 6 is 9. Nothing else changed, so we bring everything else down. And there we go. Now we figured out times 0, the times 0 equation. Another way you could have done this is you could have gone backwards on your table. 0, 9. Well, if I use this as my equation, or to help me write my equation, then I can write f of n equals, starting with a 9, adding by 6 as we go down the table, and since it's a times 0, we have 6n. And look at that, they're the exact same. So if you remember to distribute, great. If you don't, then go backwards on your table. That's why we did so much practice with that. 18, we're going to write a list of numbers that best matches the explicit. Well, this is saying f of n is equal to negative 5 times 2 to the n minus 1. Well, because of this, this is saying, hey, my first number is negative 5, so my first number is negative 5. This is telling me to multiply by 2. So what's negative 5 times 2? That's negative 10. Negative 10 times 2 is negative 20. Negative 20 times 2 is negative 40. And you can keep going forever and ever and ever and ever. But we're just going to stop right there. Okay. Same thing. Now we have, we're going to write a list of numbers that best matches the explicit formula f of n equals 60 times 1/2 to the n minus 1. Well, this is saying, hey, my first number is 64, so my first number is 64. We're going to multiply by 1/2, so what's half of 64? Half of 64 is 32. Half of that is 16, half of that is 8, half of that is 4, half of that is 2, half of that is 1, and I could keep going, but we'll stop right there. All right. In the next one, we have to find the indicated for values of the sequence whose explicit formula is f of n equals 2n plus 7. You must show your work. So what's happening is we're replacing these n's with the numbers inside of the parentheses. So let's start with the first one. If we have f of n equals 2n plus 7, and again we are replacing these n's with the number 4. So we're going to have f of 4 equals 2 times 4, because again, we're replacing that n with the 4, plus 7. 2 times 4 is 8. 8 plus 7 is 15. Final answer is 15. So let's do that again. Now we're replacing with 5. So we have 2 times 5 plus 7. And I'll make this other 5 pink so you guys see that. So 2 times 5 is 10. 10 plus 7 is 17. There we go. All right, let's do it again. Now we're replacing n with 6. So we have 2 times 6 plus 7. Well, 2 times 6 is 12. 12 plus 7 is 19. And there we go. In the last one here, we're replacing with 7. So we're going to have 2 times 7 plus 7. 2 times 7 is 14. 14 plus 7 is 21. All right, last page. Give the first 4 terms of the equation, of the sequence with the recursive formula. So we're given f of 0 equals 3, f of n equals f of n minus 1 times 4. So f of 0 equals 3. Well, here's f of 0. So get what number we're going to write up top. 3. This is telling me to multiply 4. So what's 3 times 4? That's 12. Do it again. 12 times 4, 48. 48 times 4, 192. All right. Give the first 4 terms of the recursive. So we have f of 1 equals 42 with f of n equals f of n minus 1 plus 6. So f of 1 is 42. Well, f of 1 is right here. So we're going to write 42 there. Our recursive is telling us to add by 6. So 42 plus 6 is 48. 48 plus 6 is 54. But I have to go backwards. If I go backwards, I have to minus 6. So 42 minus 6 gives us 36. So we have figured out f of 0. 23. Give the first 4 terms of the sequence with the recursive formula of f of 0 equals 36, f of n equals f of n minus 1 minus 12. This time, we're given f of 0 equals 36. But that's not here, so let's make our own. Let's say we have f of 0. We know that's 36. And on our table, it tells us to on our recursive, it tells us to subtract 12. So 36 minus 12 is 24. 24 minus 12 is 12. 12 minus 12 is 0. 0 minus 12 is a negative 12. Very good. 24, Simon is taking his 275 quarters to the bank, but his jar has a hole in it and he loses 5 quarters each second. Write an explicit pattern to show this. Formula to show this pattern. Well, if he has 275 quarters, no time has passed. He hasn't lost any of his quarters, so that's going to be times 0. However, every second he loses 5 quarters, so we're going to subtract 5. And this is all the information we need to figure out our explicit. We don't need anything else. So we know 275, we know we are subtracting by 5, and then we're going to have a regular sized n because we start at 0. Amanda already has 4 scarves. and plans to triple the number of scarves she has each month. So if she already has 4 scarves, that means at times 0, she's already had 4 scarves. If she's tripling something, tripling means times 3. So we're going to be multiplying by 3. I don't need to fill out more in my table. This is all I need to write my explicit. So we have f of n equals 4 times 3, and since it's multiplication, we have an exponent of n, and it's just an n because we start at 0. Next up, we have a graph, so we got to take this graph and again put it into a table. Table. Make a table. Okay, so we have this list here. Remember, n's are like our x's, and then f of n's are like our y's, right? If I fill out this table, f of n and n go in the same spots as where like x and y would go. So, first point, its n is 1, its f of n is 3. Second point, its n is 2, its f of n is 6. Third point, its n is 3, its f of n is 9. Last point, its n is 4, its f of n is 12. So the math that is happening down our table is we are adding by 3. So if I write the recursive out, I'm left with f of n equals f of n minus 1 plus 3. Start of the table is f of 1 equals 3. Explicit is f of n equals 3 plus 3 times n minus 1, or parentheses n minus 1, because we start at 1. Okay, that's the video for this. I'll post the answer key as well. Good luck. We're going to play a review game tomorrow.